started on today's notes over CPCTC. Now, what does CPCTC stand for? It stands for corresponding parts of congruent triangles are congruent. And I've briefly touched on this in previous lessons. You can use this in a proof when you want to justify additional pairs of corresponding parts. And all it means is that if you have two congruent triangles, you have 1, 2, 3 pairs of congruent sides, and you have 1, 2, 3 pairs of congruent angles. All corresponding angles and sides are congruent. So, like I said, I've touched on the fact that you can use it in a proof to justify additional pairs of corresponding parts. So when and how do you use it? The first is when what you are asked to prove is not that the triangles are congruent, but that maybe segments and angles are congruent, or lines are parallel, or segments bisect angles, etc. But first, before you use CPCTC, you must prove the triangles are congruent, which we've done in previous lessons. How can you prove triangles are congruent? You can use side, 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 angle, side, angle, angle, side, or hypotenuse leg. Then you'll use CPCTC after you prove the triangles are congruent to show pairs of corresponding parts are congruent. And then you might need to use additional theorems and definitions for final reasons. It just depends on what you're asked to prove. So let's get started on example number 1. We're given that segment BD bisects angle ADC and angle ABC. We're asked to prove that segment AD is congruent to segment CD. So in the previous lessons, we were asked to prove that triangles are congruent. You're asked to prove a pair of congruent or a pair of corresponding sides are congruent. So first, what we need to do is prove the triangles are congruent. Let's get started doing that. So we were given that segment BD bisects angle ADC and angle ABC. That's given. Well, what does that mean to be an angle bisector? It means that angle ADB is congruent to angle CDB. And the reason of that is the definition of an angle bisector, right? It bisects the angle, it splits it directly in half. So that's our reason for number 2. Number 3, the reason is definition of angle bisector. So what's our statement? Well, up here, it says that segment BD bisects angle ADC and angle ABC. So we also know that angle DBA and angle DBC are congruent. And the reason is that is the definition of an angle bisector. The statement for number 4 says segment BD is congruent to segment BD. We've seen this a lot. That is the reflexive property of congruence. So we've now shown that this pair of angles are congruent. This side is congruent to itself. This pair of angles are congruent. So we can now conclude that triangle ADB is congruent to triangle CDB by angle side angle. So now that we've shown or we've proven that these two triangles are congruent, we know that all the corresponding sides and angles are congruent. So because we've proven that they're congruent, we can then conclude that segment AD is congruent to segment CD by CPCTC. Corresponding parts of congruent triangles are congruent, and we've proven these triangles are congruent. Let's move on to example number 2. We are given that N is the midpoint of segment LP and segment MO. We're asked to prove that segment LM is congruent to segment OP. Again, we're not asked to prove these triangles are congruent, but we do need to prove that they're congruent first before we can prove that these segments are congruent. So our first statement is what we're given. N is the midpoint of segment LP and segment MO. The statement for number 2 says that segment LN is congruent to segment MP and segment MN is congruent to segment NO. And I've drawn little tick marks on the figure to show that. What's our reason for that? Well, that's the definition of midpoint. Midpoint cuts the segment in half so that you have 2 congruent segments. Now, the reason for number 3 says vertical angles theorem. So what would my statement be? It would be that angle LNM, here, let me get my little arrow, LNM is congruent to angle ONP. And so these 2 angles are congruent because of the vertical angles theorem. So we can now conclude that triangle LNM is congruent to triangle PNO. How? Side angle side. Okay, now that we've proven these 2 triangles are congruent, we know all pairs of corresponding parts and angles are congruent by CPCTC. So I know that segment LM is congruent to segment OP by CPCTC. And I've got my statement here and my reason here, and I drew little tick marks to show in blue to show these congruent segments. Okay, and number 3, this is our last and final example, and it's a little bit more difficult than the last or than the previous 2 examples because we are given, first off, that segment AD is parallel to segment BC. Okay, so we're probably going to be looking at some like alternate interior angles or something like that. We're also given that segment AD is congruent to segment BC. And we're asked to prove that segment AB is parallel to segment CD. So we're asked to prove lines are parallel. We've done this before. How do we prove lines parallel? We use converse theorem. So let's get started because the first thing we need to do is prove these 2 triangles are congruent. How do we do it? Well, we state what we're given first, that segment AD is parallel to segment BC. So AD is down here, BC is up here. Here's our transversal. So if I were to look at alternate interior angles, I would be looking at these 2 angles, right? For these 2 segments, these are the 2 alternate interior angles. So angle ACB and angle DAC are congruent. How? They're alternate interior angles. Okay, so alternate interior angles are congruent, or the alternate interior angles theorem, you could say. In number 3, this reason is it's what we're given. Okay, what's the other statement that we were given? We were given that segment AD is congruent to segment BC. So I'm going to draw some tick marks on there. We're given these 2. So these 2 segments are not only parallel, they're also congruent. So let's just mark it up because sometimes you can visualize it when you mark up your picture. Okay. If I'm going to prove these 2 triangles are congruent, what additional could I use to show that they are? Well, segment AC is congruent to segment AC by the reflexive property of congruence. So we now have enough information to conclude that triangle ABC is congruent to triangle CDA by what? Side angle side. So now we know every pair of corresponding parts is congruent. So all pairs of corresponding parts are congruent. That means that angle ACD is congruent to angle CAB. Those angles must be congruent to one another because these are congruent triangles. Well, if those are congruent to one another, or how do we know that they're congruent? We know that by CPCTC, right? So in this particular example, CPCTC is not the last and final reason. However, most proofs that you're going to see regarding this will be your last reason, just because this last little step is pretty difficult. So because these two angles are congruent, we know that those are alternate interior angles. So we could then conclude that these two segments are also parallel, right? Because if alternate interior angles are congruent, then BAB would be parallel to CD. So this is an example where an additional theorem is needed here because you are taking it a step further to prove lines are parallel. So use converse theorems to prove lines are parallel. And that concludes your notes over CPCTC. I hope it was helpful.